Hello friends, so here in this problem we have to evaluate limit x tends to infinity square root of x square plus a square minus square root of x square plus b square whole upon square root of x square plus c square minus square root of x square plus d square. Now if you will observe the given limit, then here we have x tends to infinity, and whenever we have x tends to infinity or limit tending towards infinity, then we substitute that variable as 1 upon t. So here I'll start with that. So here I'll say put x equal to 1 upon t, so that to make this limit finite. So let's see how it becomes finite. So when x is infinity, here we get infinity equals to 1 by t because x is infinity, and we know that we can get answer as infinity if the denominator is 0. So whenever we divide any number with 0, we get answer as infinity. So it means the answer of infinity is possible if this denominator, that is t, is 0. So here I'll say that as x tends to infinity, this t tends to 0. So therefore this limit will become, so I am assuming this limit as L, so it will become limit t tends to 0, so limit has changed to t. Similarly this function will shift from x domain to t domain. So to shift it into t domain, I will substitute x as 1 by t, so this will become square root of x is 1 by t, so 1 upon t the whole square plus a square minus square root of 1 upon t the whole square plus b square upon square root of 1 upon t the whole square plus c square minus square root of 1 upon t the whole square plus d square. Now if we will solve this, then we will get L as limit t tends to 0. This will become square root of 1 upon t square plus a square minus square root of 1 upon t square plus b square whole upon square root of 1 upon t square plus c square minus square root of 1 upon t square plus d square. Now here we'll do the cross multiplication. So here we'll get 1 plus a square t square upon t square. So therefore L will become limit t tends to 0, so square root of 1 plus a square t square upon t square. Similarly here we'll get 1 plus b square t square upon t square, and so on in the all terms. So minus, so after this if we'll observe the numerator, then here that will become square root of numerator and square root of t square will be t. Similarly here we'll get square root of t square as t, and from both these terms we can take t common. So we'll get L as limit t tends to 0 square root of 1 plus a square t square minus square root of 1 plus b square t square, and I am taking that t common from both the terms. Similarly in the denominator I can take t common, so denominator will become after this we'll cancel t from numerator as well as from denominator, and we'll get L as limit t tends to 0 square root of 1 plus a square t square minus square root of 1 plus b square t square upon square root of 1 plus c square t square minus square root of 1 plus d square t square. Now we have simplified the term, and if we'll observe, then the limit is finite, and here we have t tends to 0. whereas the function is algebraic function. So whenever we have algebraic function with finite limit, we apply direct method, and if we won't get answer by direct method, or if we get indeterminate form, that is 0 upon 0 by direct method, then we look for some other method to evaluate the limit. So let's apply the direct method over here. So by direct method, I will substitute 0 directly wherever directly in the function wherever I'll find the t. So this will become square root of 1 plus a square plus 0 square, that is 0, minus square root of 1 plus b square, and this t square is 0, so 0, upon square root of 1 plus this t square is 0, so c square into 0 is 0, and minus square root of 1 plus 0. So we will observe here, then here we are getting 0 by 0. Now when we get 0 by 0, we call it as indeterminate form, and whenever we have indeterminate form, we say direct method fails, and hence we look for some other method. So therefore here direct method fails. So now since direct method fails, we have to look for some other method. So for that, we'll again observe the term. So if you'll observe the numerator, then here we have 2 square roots and minus sign in between. Similarly in the denominator, we have 2 square roots with minus sign in between. So here I can apply the method of rationalization to remove these square roots. So since there are square roots in the numerator, I have to apply rationalization for numerator as well as rationalization in the denominator to remove the square root from the denominator. So therefore by rationalization, here in the numerator we'll multiply the numerator as well as denominator by the conjugate of this numerator. So first of all I am writing this term. So this will become L equals to limit t tends to 0. Now the original term is square root of 1 plus a square t square minus square root of 1 plus b square t square whole upon square root of 1 plus c square t square minus square root of 1 plus d square t square. Now I am finding the conjugate of numerator. So the conjugate of numerator is positive sign in between. So here the conjugate is square root of 1 plus a square t square plus square root of 1 plus b square t square. So what I am doing is I am multiplying numerator and denominator by the conjugate of this term which is in the numerator. So in the denominator also I will write down the same term. So 1 plus a square t square plus square root of 1 plus b square t square. So I applied rationalization for this term which is in the numerator. Now similarly we'll multiply numerator and denominator by the conjugate of the denominator so that the square root will be removed from the denominator. So the conjugate of denominator is, and I'm multiplying here, so that will become square root of 1 plus c square t square plus square root of 1 plus d square t square. Similarly I'll multiply in the numerator, so that will become square root of 1 plus c square t square plus square root of 1 plus d square t square. So I applied rationalization for this term in the numerator as well as in the denominator. Now let's say, so here if you'll observe the numerator or the terms which are in the numerator, then we have 3 terms, that is this first term, the second term and the third term. Out of these 2 terms if you'll observe, then the first term, that is this term, is in the form a minus b and the second term is in the form a plus b. So here I can apply the formula a square minus b square. So here we'll get by the formula of a square minus b square as square root of 1 plus a square t square, that is a whole square, minus square root of 1 plus b square t square the whole square. So here I have applied the formula a square minus b square equal to a minus b into a plus b. So these two terms are covered. Still we have one more term in the numerator. I'll write down that term as it is. So that is square root of 1 plus c square t square plus square root of 1 plus d square t square. Now in the denominator, if you'll observe, then here also we have three terms. Out of that, if you'll observe the first term and the third term, then here also we can apply the same formula, that is a square minus b square. So I'll apply here. So this term will become square root of 1 plus c square t square the whole square, that is a square, minus square root of 1 plus d square t square the whole square. So this second term. So here again I applied the formula a square minus b square as a minus b, a plus b. Now still one term is remaining in the denominator. I'll copy that term as it is. So that will become square root of 1 plus a square t square plus square root of 1 plus b square t square. So here I have applied the formula a square minus b square as a minus b, a plus b, and here we have used the method of rationalization. Now if you will observe the first term, then here this square root and square will be removed. So here we will get limit t tends to 0, this term will become 1 plus a square t square. Similarly from here square root and square will be removed, we will get 1 plus b square t square. Next second term as it is, that is square root of 1 plus c square t square plus square root of 1 plus d square t square. Now if you will observe the denominator, then similarly this square root and square will be removed and we will get 1 plus c square t square minus 1 plus d square t square. Here we will get square root of 1 plus a square t square plus square root of 1 plus b square t square. Now after this we can cancel this plus 1 and minus 1 from numerator as well as from denominator, and here we will get a square t square minus b square t square, and here we will get c square t square minus d square t square. These two terms will remain as it is. So therefore L is equal to limit t tends to 0 a square t square minus, here we got b square t square, so b square t square. Similarly in the denominator we will get c square t square minus d square t square. These two terms as it is. So the terms are square root of 1 plus c square t square plus square root of 1 plus d square t square. Similarly here we will get square root of 1 plus a square t square plus square root of 1 plus b square t square. Now from this term we can take t square common. Similarly from the denominator, from the first term we can take t square common. So here we will get L as limit t tends to 0 t square outside a square minus b square in the bracket, and second term is as it, that is root of 1 plus c square t square plus root of 1 plus d square t square whole upon here we'll get t square common, in the bracket c square minus d square, and in the second term we'll get square root of 1 plus a square t square plus square root of 1 plus b square t square. Next we can cancel t square from numerator as well as from denominator, and if we'll observe again, then here again we got algebraic term and t tends to 0. So whenever we have algebraic term with finite limit, then we apply direct method. So here once again I'll apply direct method. So by direct method we will substitute the value of t equal to 0 directly in the given function, and here we'll get L as now a square minus b square as it is and c square minus d square as it is. Since it does not have any t term, this will become square root of 1 plus t square will become 0 square, so 0 plus square root of 1 plus 0 upon, here we'll get square root of 1 plus 0 plus square root of 1 plus 0. So this t square term will become 0. Next this will become root of 1 plus root of 1, that is 2. Here also 1 plus 1 2, and we can cancel that 2, and therefore we'll get L as a square minus b square upon c square minus d square. So the value of given limit is a square minus b square upon c square minus d square. Thank you.